to simplify that? That would be good for us. That was good for that university. Does anyone have an idea what they were calling for there on that final exam? They say simplify that? Jacob?
Well, I would take out the negative.
I would too. He says, wait, first, this negative sign bothers me. The cosine has been identified as what, even?
Mm-hmm.
So I can wipe that out right now. Which is a big help. And then, Austin, what would you suggest next? Common denominator. The common denominator, right now in the raw form you see is 1 plus cosine x times 1 minus cosine x. And he wants a common denominator which says, well, be patient. This one is missing the 1 minus cosine x, so put that in here. And the second is missing the 1 plus cosine x. So I gotta put that in. And we have that. You guys agree? Now this is my common denominator. Guys, on top there, I think I end up what? 1 subtract cosine x on the first one? No, let me make a mistake here. And down here, what's that? 1 plus cosine x, yes or no?
Yes.
And all over that common denominator. If I take a closer look, I think they're in that purple color there, I guess. These cancel out, that's cute. You end up with 2 over this, and you should recognize if I expand this out, it says 1 subtract cosine squared, which I think we all know could be replaced by with an identity as what? Sine squared. I mean, this university really did it. And then they had their test in multiple choice format. And then they didn't stop there. Does anyone have another name for this? They did a little further. They broke this up into this first. 2 times 1 over sine times 1 over sine for that 1 over sine squared. Yeah, I think those were cosecants. So in fact, cosecant times cosecant, and this is what they were looking for an answer. Done. Now, could you guys do one like that for me on the final exam?
Yes.
If they did it at this university, we should better do it. Okay, it falls right in line with what we've been doing here. Okay, guys, I'm gonna call this letter A. Let's see what letter B is. Let's see if it's another simplifying here to work with. Okay, this one looks like this. Cosine of, let's just find the exact value. Cosine of negative 7, 5, or 12. We had somewhat of a discussion with this type in the 4 o'clock session. I would assume, Nathan, I can drop the negative sign.
Yeah.
Which is just in the way there for that. And think of it like that. Now guys, you know I would give no formulas on the exam. So you got tons of formulas that you have to have in your head. And you say, well, Professor, which one should I use? It may be up to you as to which choice. And if you show me with your choice that works out, I'll give you credit for it. Matthew.
Okay, cosine pi over 4 plus pi over 3.
Hang on now, pi over 4 plus pi over 3. If I use a common denominator of 12, I see he is correct. He broke this up. Now, Matthew, with that help, he has this now in the form of cosine what? A plus B. Well, that means there's a formula needed. And the formula for cosine A plus B, guys, is what? Cosine A.
Cosine A, cosine B.
Cosine B. Minus what? Sine A? Sine B. These are just things to close down this trig part of the course. And he gave me pi over 4, so this is cosine pi over 4. This is cosine pi over 3. And minus sine pi over 4. Sine pi over 3. And if I start making replacements, guys, and we all should know from the unit circle, This is what, radical 2 over 2? Oh, wait, does anyone recall what cosine pi over 3 is?
Over
that's
2.
Don't scare me.
one.
Don't scare me. What's cosine pi over 3? Is it 1/2?
Yeah,
Yeah.
1 over 2.
Well, it's not radical 3 over 2. I heard that. Sine pi over 4, radical 2 over 2. And sine of pi over 3, is that the radical 3 over 2?
Yes.
And if all that's together, I can write my final answer as radical 2 subtract radical 6 all over 4. And you're finished. Now, alternative, if I just say find it, not tell you how to find it, an alternative to get that answer up here. Now, this may not look the same, but it'll work out. Cosine of 7 pi over 12, if you guys will agree, could be for this alternative method, written as cosine of what, 1/2. What was that, 7 pi over 6? That true, guys? And then you could go through a half angle formula and give me that answer. Even though that answer is going to look nothing like this, but they are equivalent. So it's up to you. So know your formulas. I used an A plus B formula, and this really is a half angle formula. I'll point that out before we finish this up. Next, I have, yes, letter C. They have on their test to simplify, which I thought was really cute, this. They have sine double X over 1 plus cosine double X. I think you're going to be shocked what that simplifies into. Does anyone think they know at this point how to start?
Can we do the double
Guys, are your formulas?
formula on top and on bottom?
Now, Jacob, do you recall what the sine double theta formula was?
Well, isn't that sine?
Two.
Sine,
Two.
oh, yeah.
It is. Guys, got your formulas. Now, the one on the bottom there, cosine double extra, they got a 1 out front. Guys, this one, if you know your formulas, cosine double theta, this is one that has 3 versions. And I think I started out with cosine squared minus sine squared, and then I give you the other 2 versions that we derived real quickly. Should I use cosine squared minus sine squared, or should I use one of the other 2 versions? And it might make a difference in what they want here. What do you think? Or should I jot down all 3 just for a little reflection of what these were? Now, you might put this. I'll put theta there rather than X, that's okay. I think this was the first one. And then we merely clean this up a little bit. We replaced cosine squared with what? 1 minus sine squared. And we said, if you need it, another version could be written like this. Easily derived. And if you need it, it all depends on the problem, you could replace sine squared on the end up here as what? 1 minus cosine squared. Clean that up, and I think that came out to be this. And see if you guys will agree. Is that what we had? Now, of those 3, this, which one looks like it might help me to simplify this altogether?
Number 2.
Okay, let's try number 2. Let's see what he's got in mind. So leave the numerator like it is. Jacob says, go down, Professor, and try this one. 1 subtract 2 sine squared theta. Jacob, what do you got in mind?
Is it 1 plus?
Well, wouldn't we, 1 plus?
Where's that now?
Cause that's a.
Plus here.
Yeah.
Yeah, 1 plus out here. But you said use that particular formula. Is that true? Then if I try to clean it up, Jacob, I think maybe you have in mind, but you can certainly stop me and tell me. We're gonna leave this as 2 sine x. I'll put my x back in there, guys. Cosine x. And here, that becomes what? 2 minus 2 sine squared x? Yes or no?
Yeah.
Put these together? Is that true?
Yeah.
Then, Jacob, tell me now what might be.
Could you not factor out the 2 on the bottom?
You will. And if you do, you're gonna end up with 1 subtract sine squared. And you're not finished yet. Now what? Can I go further? Yeah, what's 1 subtract sine squared, guys, equal to?
Is equal to
Cosine square.
Yeah,
No,
cosine
cosine
squared.
squared.
You're going to end up with, I don't know why I put that square there, I was thinking about square. 2 sine x cosine x over 2, what is this cosine squared? All this right here is cosine squared. Yes?
Yep.
Yeah.
Now, if I simplify this further, the 2's cancel, you're talking about a nice university problem. This cancels, one of these will cancel. So I'm left with sine over cosine,
Or tangent.
which is tangent. Who on earth would think? Here's the original problem. This is the original, it comes out to be this. Know your formulas. For goodness sakes, you gotta know your formulas. Okay? And I think I had one more here from that common final exam to point out before I close this down and get back to where we should be. Yes, this one. Simplify this. 1 plus 10 squared x and multiply by 1 plus, I hope everything's copied down correctly, cosine 2x. Is that in parentheses? Okay, it's copied down correctly. You may be shocked what this one comes out to be. I think this university was, UC San Diego was using this. Okay. Any ideas?
Convert tangent squared of an act.
Well, in fact, I could convert.
Oh wait, couldn't you convert the
It's
whole?
1 plus 10 squared directly something.
Yeah.
Secant squared.
It's secant squared, isn't it?
Yeah.
So this could be quickly just replaced by this. Even though, Jacob, you could play around with it and probably end up with the same replacement. Now I have on the side here 1 plus cosine double x, not 1 plus cosine x. So that means here, I need to come up with a formula for, oh my goodness, here we go again. Cosine double x. Does anyone recall a formula for cosine double x? Somewhere in here, I don't know. Did we do something with cosine double
Yeah,
x?
didn't we have it right there? We have the 3 formulas.
Okay, so which one might be advisable to use here in this one?
Maybe cosine squared theta.
Well, we started out with cosine squared minus sine squared. That was the original, wasn't it?
Yeah.
Somewhere back in here. Was it, guys?
Yep.
Cosine squared minus sine squared? Oh, right here it is. For cosine. And then we wrote these versions here.
Maybe the top.
So this, or this, which one do you think might be best here? If I see a secant, I usually think what is associated with it?
Cosine.
Cosine. So I might
So
wanna
number
use
3.
this one.
Yeah.
And we're taking a guess at may. Okay, so 2 cosine squared minus 1. Then parenthesis, and close that up. And look at this. We got secant squared. We'll use the black marker. Guys, one's canceled. And you got here what? 2 cosine squared. Please tell me what's the answer.
2.
2.
Yeah.
This right here could be expressed as, we all know, 1 over what? Cosine squared?
1 over cosine squared. And then it would cancel out with the other ones.
There you
You'd be
go.
left with 2.
And of course, we have this on the end. He's telling me these cancel, Professor. answer 2. Now you're talking about frustrating. After you look at this on an exam, and I know an exam you're under a lot of pressure, but you look at it, and look at it, look at it, and all of a sudden you talk to your classmates as you leave. What'd you get for that one? What'd you get for that one? Oh, I got secant squared subtract 4 cosine theta. I'm sure that's the answer. And then Nathan says, nah, the answer's 2. You talk about frustrating. When you talk to someone like that and you say, what? 2? And they have this long, lengthy answer? Yeah, this one's simplifies to a 2. Guys, that's what I want to do from that university sample. Okay? Now, Jacob, help me out.
Yeah.
Go back to, my goodness, here's what I want you to go back to.
Right
Well,
here.
before we jump into it, I thought about this driving in today. Go back to where it says double and half angle formulas. Do you have that handout also? Do you have all your handouts organized?
I have the.
I think it's section 6 point something. I think it says double and half angle formulas. Before I leave this.
Yeah.
And was there a continuation of that on the next handout?
Yeah, there's a continuation of it on the back of the handout.
Okay, half angle and double angle.
Yeah, and we talk about law of sines and law of cosine.
Okay, okay, I'm not quite there yet, because I thought about this driving in. Was there one on there where they asked you to solve an equation and there was a double angle formula involved?
I don't know which one you're talking about.
Yeah, I noticed that on my handouts, guys. Does anyone see that where it says solve and there's a double, yeah, I see it right there.
Oh, this one page.
Yeah, she has it.
Formula. Is it sine of 2 theta? No, wait. Yeah, wait, is it just sine of 2 theta?
Okay, it says solve, doesn't it? Somewhere in there?
Oh, yeah, sorry. Solve the given equation on the interval of 0.
That's what I
and
need. That wasn't said.
pi. It's a sine of 2 theta equals cosine of theta blank.
Equals cosine theta.
Yeah, and then blank.
And then they want the answer for us. Looks like that. Okay? What are you gonna do? I think we sort of got up to this point when I was with you guys last time. Well, you gotta know your formulas. Does this require a formula?
Yes.
Yeah, sine double theta, which I used over there, could quickly be written as what? 2 sine theta, cosine theta. And of course, this is equal to cosine theta. Now, someone in this accelerated class tell me, oh, that's true. What would one do from there?
Move cosine over the other
Thank
side.
you. Move cosine over. And write like this. I don't know why the next there, theta. Is that true, guys? Let's move the cosine over. Now, why did the student want me to move cosine over?
Because you can factor it out.
You can factor it out. Take out cosine theta on the left, and you're left with, that should be a theta there, not x. You're left with 2 sine theta, subtract 1. Guys, we agree?
Yeah.
And now, I think everyone would be ready now to say, wait, Professor, you can split this up. It's like an algebra equation, and set each one of these equal to what? 0? And solve. Let me go ahead and solve this one quickly, and then we'll get back to the answers. This is sine equals 1/2. Now, this is merely a unit circle. So where on the unit circle have you seen cosine equal to a 1? Or have you?
0.
0. At the very beginning of the unit circle. I think there was it.
Is it 0?
There should be.
Was it cosine's equal to 1?
No, because
Cosine equal to 0.
Or was cosine equal to, oh,
Yeah,
yeah,
we're
0
making
here.
0 though.
Yeah.
Now that's gonna change to what then? Pi over 2?
5 over 2 and
3 pi over 2. I thought the word caught something down wrong here. This one, sine's equal to 1/2. Have we seen that before?
5 over.
5 over 6?
Yeah, and.
And 5 pi. You gotta know the unit circle. Of course, you should list all those together, but I'm doing this quickly for recap, these are the 4 answers. Whoa. Now, I don't know, I was not gonna show you all this, and I was gonna just, you'll probably see this for the first time on your final. I thought, no, that's not quite fair. Let me at least give them a glimpse of what it might look like, okay? Jacob, what else was I asking to be done there?
There was cosine double theta plus 5 cosine theta.
Hold on, plus 5
Yeah,
cosine theta,
plus 3
okay?
equals 0.
Beautiful. Beautiful. Nathan, any ideas?
Oh, I mean, you can kind of do, you can use the formula.
There's a formula needed.
Is it third part?
It's right here. Now, thinking of which one should I use it, because this one has 3 versions. 2 cosine squared theta. What, subtract 1? Look at that. And then leave the other, Sophia, leave the other like this. Guys, clean this up a little bit. This is 2 cosine squared theta plus 5 cosine theta. I guess, put my numbers together, -1 plus 3, was it plus 2? And then it looks like this might be calling for you to do what at this point? There you go, you guys are good at that, let u be something. In this case, cosine. And rewrite this, make it look nice, as this. Factor. We'll end up with 2u. U, watch my factoring, you guys, plus 2, I think, plus 1. Let me step back and look at it. Split this up. You're considering u to be what, -1/2?
Yeah.
And u is equal to a -2, was it? Is it true? Look quick. And of course, this is cosine, so this is cosine theta equals a -1/2, and cosine theta is equal to -2. Wow. Any mistakes there? Real quickly. Are we okay there?
Can we disregard the right?
Yeah, this is impossible. The cosine parent graph drops down to, for a minimum, what? -1. So this is out. Can't use it. This, though, from the unit circle, you have to recognize, where have I seen cosine, the x-coordinate, equal to a -1/2?
2 pi over 3,
Out here, 2 pi over 3.
4 pi over 3.
Out here, 4 pi over 3. And you're finished. No, that unit circle. Oh, my goodness. Okay, Jacob, was there anything else, just to make sure I have everything done?
There was find the exact value of the given expression.
Okay, now let's squeeze that in right here. Like, what did they give you?
Cosine of 2 inverse sine of 3 over 5
Whoa,
equals blank.
2 inverse cosine.
No, cosine, just normal cosine, not, no
Okay,
2.
Okay,
No 2 in front of it,
no 2 here.
no 2.
Okay,
Of 2 inverse sine.
like this.
Yeah,
Beautiful. Was that x or theta or what?
3 over 5.
Oh, 3 or 5. They gave you a number. Okay. Okay. Interesting. This is something like you guys had on the last exam. Isn't it? Did you guys have something like this to do for me on the exam 5? Of course you did. Except, what's the difference? What? Am I repeating something we've already been
Yeah,
tested
2
on?
inside.
Yeah, 2. This says double theta. Did I see that too? That represents the double angle formula. And think of this cosine 2 theta Guys, I'm gonna use the first version. What is it, cosine squared, subtract what? Sine squared? You can use other versions if you wish. I'm gonna try that one. Okay. Is that true? Just that two there alerts me to it's a double angle formula. Then, he gave me this, which I know means there's an angle out there whose sine is 3/5. And by restriction, I should be caught between what? Negative 5 or 2?
Negative 5 over 2 and 5 over 2.
5 or 2.
So, could we do a triangle?
Now, exactly. If I do not insist, or have a note there to use identities, like I did on exam 5, quick way is go to a triangle and say, Professor, this angle you're talking about is in quadrant 1. Anyone tell me why it's in quadrant 1?
Because sine's positive.
Yeah, sine is positive 3/5 here. And he says, Jacob wants to do this, drop a perpendicular and show that sine is 3/5. One way to do it, I've seen students do some things on the exam 5. Some students did this, and knowing that this should be a 1. And then they used the Pythagorean theorem and found the other side. Does anyone have an idea what this other side, c squared is equal to a squared plus b squared would be? Is that 4/5? 4 over 5, 4/5?
Yeah.
That's right, and it's in a circle for us now, so I should be able to just read directly, I hope, right? Yes or no?
Yeah.
And here we have cosine squared, cosine is 4/5 on this.
Or 20, 25. Or
16
not 20, sorry, 16.
16, right, and sine is 3/5. So we end up on 16 subtract 9, I guess?
25.
7, is it? Over 25. And there's the answer. Now that's putting stuff together.
How would you solve without using,
Did we do good?
how would you solve without using the triangles if you ask for us to do it?
Yeah, if you want to do the triangle, oh, without the triangle.
Yeah.
Gotcha. Hang on now. If I'm still use this, you can say up here sine is 3/5. You can do it, use the triangle. If you don't want to use the triangle, you can say, well, sine squared plus cosine squared. That's an identity, it's equal to 1. And I know what sine is, that's 3/5. So I put that in. Guys, we'll do this fairly quickly. Most of us are arithmetic here, that's 9 over 25, move that over. I think you end up with 16 over 25. Help me out.
Yeah.
Is it? And then do a square root. I guess it's 4/5.
Same thing.
Okay, and then put these in. You got it. Good question though, just in case I say use identities. Yes?
Also, like, can we use like the opposite, like adjacent
Yes,
and
opposite
stuff?
of hypotenuse,
Okay.
adjacent of hypotenuse, absolutely. If I leave it open, just say find it. I may not say use identities, just find it. Either triangles or identities. Jacob, please tell me, is that it?
That is it.
Woo.
For that worksheet.
For that one?
Yeah.
Absolutely. Now. Guys, I got something to point out here right quickly. Jacob, would you now find the handout as we close this down? Where the law of sines, law of cosines,
Yeah,
I think I had
yeah.
a couple of triangles drawn there to look at. Would you remind me what that was?
Well, we had law of sine and law of cosine.
Now, guys, you got into the law of sines, law of cosines, we had those other handouts, and I
We
showed you.
derived it.
I derived it.
previously.
Now, did I have a triangle or a couple of triangles to solve?
We had already solved 2, and we have 2 more to solve.
Oh, really? We already solved 2. Okay, tell me what the next one is, and I'll take a question. Yes?
Do you have an extra?
I'll have to find it. I don't have it right here handy right now. Okay.
I don't, we might have already done this one if I'm not mistaken.
Okay, remind me.
It's solve the given triangle,
Okay.
and we have a triangle with the points labeled A, B, C.
Now, tell me first, is it a right triangle?
No,
Okay, so it's either law of sines or law of cosines will be needed.
yeah.
Did it look something like this, I guess, like this up here, or? I don't know exactly how that triangle looked on your hand.
It looks like almost a 90-degree angle going upwards, so it might be a little bit, but,
A little bit off here?
yeah, but that's fine.
Okay. And I labeled this as what?
The top point is uppercase B,
Okay,
and then directly across from that is lowercase b.
right here?
Uh,
Oh, okay, gotcha.
yeah, downward. And then A is on the left side,
Right here,
yeah, and C is on the right side.
gotcha.
And we have been given, uppercase A is equal to 40 degrees.
Hang on.
Uppercase B is equal to 60 degrees. And lowercase a is equal to 4. And we need to solve the given triangle and find the area.
Beautiful, and then find the area. Okay. Now, on the final exam, I could leave that 60 in there for you guys to work with. You should know how to deal with 60 from the unit circle. I would have changed that 40 though to a 45. If I intend for you guys to finish it up with a non-calculator approach. So let me do this, even though it says 40 on your handout. Let me change this to 45, guys, and let's just see if it'll work for me. I'm just wondering if it will. Let's try that. And see if I can, with those new numbers, find the solutions without using the calculator. Now, law of sines, or law of cosines, and both those are on your handout. Guys, sometimes it takes a little time to think, well, which one would be most appropriate with what you see, because he's asked me, I think, to find all the missing parts. And I think most students seated for saying, Professor, please go ahead and find that missing angle first. These two would add up to what, 105?
Yeah.
So this is what, 75, is it?
Yes.
Let's get that out of the way first. Now, based on what you see, would you do it by law of sines, or would you try law of cosines?
Law of sine.
Now, if you want law of sines, match things up for me first, we point out we want to use this. Even though some students may use law of cosines and make it work. Now, someone match up things for me for the law of sines.
Wouldn't it be sine of 45 degrees?
Beautiful, hang on now. Over 4 equals
Then it would be sine of 60
60
degrees.
over
B.
B. And that will allow me to find B. And since I now have angles from the unit circle, no calculator's needed. Guys, this is radical 2 over 2 over 4. Over here, sine of 60. Who recalls what sine of 60 was? Sine of 60.
Yeah.
Was that radical 3 over 2?
Yeah, over 3 over 2.
Yeah.
Got some strange replacements, but that can happen. And then solve for B. You can quickly cross multiply if you wish. I've got some strange numbers in here. And write this as radical 2 over 2B is equal to, in this direction, guys, right now it's 4 times radical 3 over 2 if we are correct. Simplify this, that may help me, that's 2. That's radical 2 over 2. B is equal to 2 radical 3. And then what would you suggest I do next?
Divide by radical 2 over 2.
Divide by radical 2 over 2, I'll take that. Looks awkward as you know what. These cross out, and we end up with B is equal to, now guys, here's where we might mess up. This says 2 radical 3 is being divided by radical 2 over 2, which is what? 2 radical 3 times, flip this over. Is that true? So we got 4 radical 3, Matthew, I need you here shortly, over radical 2. Matthew, what would you say the final answer looks like?
That would be 2 radical 6.
Oh, just 2 radical 6 I heard?
Yep.
Well, it's 4 radical 6 first, over what, 2?
Over 2.
And of course, 2 into 4 gives you 2 radical 6. And Jacob, we just discovered this is 2 radical 6. And therefore, this triangle is finished, solved. But I think I heard you say something else.
We need to find the area.
Oh my goodness, that's another formula. Did I discuss area?
Yeah.
Did I give an area formula on the handout?
No.
No. So someone's going to help me out. Now I want the area of this triangle. I know what some of my students will do. They'll do what the kids across the street will do. They'll drop a perpendicular down to the base, form a couple of small right triangles, and deal with it and find the area by dropping that perpendicular. I think I somewhat did that in class probably last Wednesday and came up with maybe a formula for the area. Does anyone recall what a formula for the area of a triangle, general formula, looks like?
A equals 1/2 BH.
Okay, that 1/2, but then I think I expanded and made it look a little bit better. I think it was 1/2 base times height.
Yeah.
But then I did a lot of work to it, and we came up with a formula for the area
Isn't it?
of a triangle.
A is 1/2 C B sine.
Wait, BC?
Oh wait, no, this is just proving the
Okay.
sine, yeah.
Okay, I'm thinking, what was this? I know I used it for law of sines. I used that to find the law of sines. Does anyone remember what it looked like before I did what I did to it to get the law of sines?
It's just
I had
area
something
equals-
here, equal to something here, equal to something here, we cleaned it up, and it came out to be law of sines. Can you tell me any of those
Sine
forms?
of B equals,
Okay, 1/2
BC sine A
BC, I hear sine A,
equals 1/2
or 1/2, help me out,
AC
It's
sine
even.
B,
what was it again?
AC sine B,
AC sine B, or,
1/2 AB sine C.
thank you. Any of those would work. And then I used that and cleaned up to get the law of sines, to derive the law of sines. Guys, I'm gonna try, since I have the triangle in front of me, I'm gonna try this one. So 1/2 A, lowercase a was 4. Lowercase c, did we find lowercase c?
no.
Oh my goodness, I didn't find it, I need it then. Okay. I thought we were finished. Okay, guys, how am I gonna find c before I get back there?
You have to use the law of sines again.
Now. Trying to find
Or
that.
you could use the law of cosine.
If I use law of sines, tell me what the law of sines may look like if I'm now trying to find c.
Well, if we use sine A, it would be sine 45 degrees.
That was gonna give us 3y,
Over 4
okay?
is equal to, and then sine 75 degrees over C, but we don't know sine 75 degrees.
Although sine of 75 is
The same as
30 plus 45.
30 plus, see what would happen? That 75 for really clever students, they wait, professor, I can still do 75. Make it 30 plus what, 45? And then all of a sudden, you're over on the side in another formula, sine A plus B, and you gotta come back. Oh, we're gonna have fun. Are we gonna ever have fun on this, jumping back and forth, back and forth, back and forth from one formula to another? Let me just go ahead and set this up. Susan, I may ask you to find sine of 75 degrees for us here shortly. But right now, I would have radical 2 over 2 C is equal to 4 sine 75 degrees. Oh my goodness. Here we go. I may have to call on Matthew again. Guys, please tell me, right now at this point, would this be 8?
Yeah, 8 sine 75 over root 2, which then, that would be root 2, that would be root 2, 8, root 2.
8 root 2.
Yeah, 8 root 2 sine 75 over 2, which we could then divide, making it 4 root 2 sine 75.
Wow. You guys agree? That kid just said it like that. Susan, calculate this for me, see what that's close to. It's a mess.
Sine of
Yeah, sine 75 degrees, then times radical 2 times 4.
Radical 2 times 4 is 5.46.
And then times sine 75 in degrees.
Oh, like everything.
Everything, oh.
Is 5.46.
Oh, it is, 5.4 something?
4.6.
4.6. Now, I could not do that to you on the exam. And then what I need then is, what, replacement for C now?
Mhm.
What was that, C was what, again now, 5.46? Right in front of me here. Sine, what was it, angle B, what I chose, and that was 60. And guys, I'm not gonna finish it up for you, you know, to calculate that and find out what that's close to. Is that true? That's where you find the area. How do I think of it before I leave it? If they ask you to find the area, you're gonna take 1/2 the product of two sides, you choose the sides. If you choose B and C, then you have to multiply by sine of the included angle, the angle caught between those two sides. So B and C in my case were here, that's angle A, and that's what I had. If I choose sides A and C, these two, the included angle is 60, or angle B. And of course, you could try the other choice. Woo, are we gonna have fun? Jacob, please tell me, is that finished?
That equation, yes, but we still have to do other things.
Like what?
Well, we have to go over the law of cosines, Professor.
Did I at least give you the law of cosines formula Wednesday of last week?
No.
We didn't see it. Oh, my goodness. Gotta do it. And I'm going into chapter 11. Just took a little bit of piece of time here, which is okay. Law of cosines? Oh boy, how am I gonna do this? Did I have the law of cosines written on the paper?
Yes.
Let's accept what you see. I know I could derive it. I don't know whether I derived anything at all last Wednesday for law of cosines. It would take a little time. I could certainly draw a triangle, draw up a perpendicular, and go through all that business. You've got to actually do it. Did I have the first version as a squared first?
Yes.
It was b squared plus c squared.
Minus
Minus what?
2bc
bc.
cosine A.
Now they end this with cosine. That's what they call law of cosine. Angle A. You'll say, Professor, oh my goodness, another formula. It is. Now those guys, one thing I noticed about the law of cosines, there's 3 versions here. If I start out with A, I'm going to end with A. That's where it helps me to remember what to do here. I start with A, and we're in with A, and of course cosine for the law of cosine. Nathan, it could be B squared first is equal to this minus twice the product of those two sides, A and C, cosine of, and I'll end with B, capital B, as I start out with B. Now someone tell me the last version.
C squared.
C squared is equal to
A squared
plus
B
B
squared.
squared, subtract.
2ab cosine capital C.
Thank you. Now, if I jump in and try it, just use this. The last one looks so familiar to something you've seen since grade 6. Does this one look so much like c squared is equal to a squared plus b squared?
Yeah.
It does. Now, let's be clever. C squared is equal to a squared plus b squared, Pythagorean theorem, works only for what type of a triangle?
Right.
Triangle.
Right. So if you say, wait, Professor, you mean if this angle here was 90 degrees? A right triangle? Cosine of 90, cosine of pi over 2 on the unit circle is 0. That would force this entire term to drop out. And you're sure enough left with c squared is equal to a squared plus b squared. If angle C is a right angle, if a right triangle. So that Pythagorean theorem is just a special case of the law of cosines. Now though, are you telling me I need to solve something? Jacob?
Yes.
Okay, what is it?
Solve the given triangle.
Now, I don't know what the triangle looks like, maybe I'll make another
You
one.
could just use the other one if you.
Okay. Was it labeled the same way?
Yes, it was labeled the same way. No, A and C are switched.
Okay, A and C are switched, so C's over here,
Yes,
and A's here.
yes.
Okay, hang on. This is A, this is C, B's here,
Mhm.
and B's here, right?
Yes.
Okay, now what did, on earth did I give you?
You gave us that a, little a, lowercase a,
Okay.
equals 2,
Wow. Okay.
lowercase b equals 3, and uppercase C equals 60 degrees.
At least that's an angle from the unit circle. And did I ask you to find a particular missing part of that triangle, or did I just say solve the triangle?
Solve the given triangle.
Oh, my goodness. Okay, that's fine. Guys, I would think, can I use law of sines on this one?
I don't think you're given enough info.
That's why I did this. If I were a student, I'd say, wait, professors use law of sines on this. And write this as sine 60 over what, C? And then sine of what over what?
Then you
I don't
get-
have another what? Do I have an angle missing? I can't use law of sines. That's why I need this. I've got to use law of cosines. Some textbooks will even give you a law of tangents. Okay, now, can anyone tell me, with the law of cosines given to you, I can't use law of sines, not enough information, which of these would you like to use? And I'll set it up.
C squared.
C
I'm
squared.
gonna try this last one. Okay, so C squared is equal to, says A squared, that's 2 squared for us.
Which is 4.
B squared, what, 3 squared? Subtract twice their product times cosine, of course. And that's, since I started with C, what was that, 60 degrees? Did we set that up correctly?
Mhm.
And if I'm crunch this out, it's C squared is equal to, what's that, 13? And guys, I think this is what, 12? Help me out.
Wait.
Cosine 60, is that 1/2? If it is, that is really cute. Is cosine 60 1/2?
Yeah.
Yep.
Yeah, so this is C squared is equal to 13 subtract 6, which is 7. Oh, wow, are you kidding? There's the length of C. This is radical 7. Done. Just plugging numbers into the law of cosines. Now, I'm not gonna completely finish it up, but I will. Nathan, we're gonna try to find one of the angles, angle A or angle B that's missing. Do I have enough now where I could turn to law of sines?
Yeah.
Now, is it risky? It's risky because if I miss this, I made a mistake and I missed this, and then I use it with the law of sines to find another part, I'm gonna miss the other part also. But let's take a risk. Tell me what the law of sines will look like. Sine 60
Yeah, sine 60
over
over,
radical 7.
radical 7.
A little risky. Give me another match.
We don't have sine B, but we have sine A.
Okay, which one will we use? Will we use A, sine of A?
We do sine A over
2.
2.
Is that true, guys?
Mhm.
And there's other ways to set it up. And if I do a quick cross multiplication, guys, let me try and get this done. You end up with sine A is equal to 2 times sine 60, multiply these two together. And sine 60 is that strange what? Radical 3 over 2? I think. It is. Of course, that's all over what? Radical 7? I did it quickly. You guys agree? 2's will cancel. You're going to end up with, Matthew, help me out.
I think root 21 over.
It is. Over what?
7.
Beautiful. Now you say you're finished. I blocked it off. No, they're asking to find angle A. I'm not quite finished. I got sine A is equal to this. I want A. What must you, Sujin, now do for me
Figure,
to find out what angle A is? Angle A is not that.
And take inverse.
You gotta do an inverse. So A is gonna be equal to inverse sine of that strange number. And I cannot do this on the exam unless I give you numbers you can recognize. Susan, find an inverse sine of radical 21/7, and we'll stop. Wow,
It's 40.89.
40.89. I guarantee you, Nathan, you and Austin will walk out final exam day exhausted. And you ask Austin, Austin, what'd you get for that answer? No calculators. Austin will say 40.89. What? What? Austin will say, well, he may know something that maybe no calculators needed. Now, would I do that too for a class? No. I think give you numbers that you could recognize. Guys, you okay? Now, by the way, the other angle would be easily what? The two that we had, we got 60, and this one she gave me, that's 100 plus something.
Yes,
Then subtract from 180.
79.11.
70 point something or whatever.
79.11.
What is it, 79? Yeah, you could do that. All three should have the 180. Oh my goodness, am I glad to announce that this is over. That was like it, wasn't it?
No.
What,
Still
what's,
have
what,
one
whoa, are you kidding? What am I doing here? Come on. Okay, I have this for an extra credit. I think I've won the extra credits on the final looks something like this one, so I guess I should do it. You guys would like to see it or not?
Yeah.
Oh, look at that, oh,
Wait,
look at that.
You said extra credit on the final?
Oh, there's some extra credit. There's some extra credit. Okay. Jacob, I remember what this, it was a circle
Circle with a triangle in it.
and
Oh, that's beautiful.
a triangle inside.
Yeah. This stems from the center point.
Okay, so there's a center here. And I guess I had drawn out something like this maybe.
Mm-hmm.
And then maybe out like this.
Yes.
Okay.
And then you connected the two, where the two lines meet.
And I connected these two.
And you shaded in the area.
Oh, extra credit. Oh my goodness.
You said we need to find the area.
And I asked you to find the area of not the circle, not the triangle, but this little piece. I think they call this a section of the circle. Find the area of that. Now that would be a nice extra credit. But I must give you some numbers to work with. Jacob, did I place any sizes in there for you?
Yes.
Like what?
At angle C,
Uh-huh.
there's 60 degrees.
Yeah, we can work with that.
And we know that the radius is 8 feet.
8. Oh, we can deal with this one. You guys are going to take a break. And I'm gonna start chapter 11 with my favorites coming up. Okay, let's get started. I would suggest, just to sort of guide you, I would first suggest you find the area of the full circle from across the street. The area of the full circle, guys, we know what it is, absolutely. It's pi r squared. The radius he gave me is 8, so it's pi 8 squared. I'm looking at 64 pi. I'll give you partial credit for showing me that. That's the entire circle. But that's not what I have shaded. That's not the answer. Number 2, what else do you think I may want to find the area of?
The triangle.
The triangle inside there with that area for me we discussed earlier. Guys, the area of the triangle. I gotta be careful here. Anyone tell me what you would do to find, taking note of what we did over here in our discussion, 1/2 business. What would you say I could do here? Now you know this is 8 also. That's another radius. Could I take 1/2 of, help me out here guys, 8 times 8?
Mm-hmm.
Sine of what?
Sine C.
That's it. Probably about 88. 8 times 8. You guys agree?
Mm-hmm.
And therefore, if I clean this up, guys, I think it's 32 Sine of 60, oh my goodness, that's a strange number, radical 3 over 2, isn't it? So this is 16 radical 3, if I cleaned up. Let's step back and look at it. You guys agree? Okay, now you get partial credit. Now you know the area of the full circle, you know the area of the triangle. What are you going to do to find the area of that little slither shaded in?
Need to find the area of that wedge, right?
Yeah, this little piece here. What might you do here now? Are you going to subtract the two? Are you going to take the full circle? There's all this in here. This is the area.
Like an area of just that part of the
Yeah.
circle.
And, okay, thank you, and you say, Professor, it should just be maybe, here we go, I heard what you said, Austin. You say, wait, Professor, it is just this piece of the circle here. All this in, and here, and this.
Yeah.
Is that true? I need to find the area of that, true? And then subtract the triangle.
Yeah.
Now, I have the area of the full circle right now. Does anyone have a clever way to come up with, they call that a sector, by the way?
It's a 1/6 of the total.
Okay, let's see now. Let's write this as area of the sector. Before I jump in and agree with Austin, guys, a clever way to find what that is, you got a 60-degree angle to work with. What is the degree measure of a circle to begin with? 360. Well, I don't have 360, that's a full circle. I have 60, so I could get a comparison, a ratio, and compare 60 to 360, which I heard Austin tell me, Professor, that's 1/6. Is that true, guys? Of what? Of the full circle.
Yeah.
And the full circle was 64 pi. See if you guys agree. Yes or no? And then clean this up the best I can. I could reduce this down somewhat. Make this a 3, make this a 32. So we end up with 32 pi over 3 if I have no mistake. Now that's the area of the sector. Now, am I ready now to subtract? Okay, so number 4, I'll write this as now the area of the shaded. That's what they wanted. Should be what, subtract what?
32 pi over 3
32 pi over 3.
minus 16 root 3.
The triangle 16 root 3. And you know I would not ask you to calculate that just using that form. And that would express the area of that purple piece up there. Do you guys agree?
Yeah.
Would that be a nice extra credit? If you see it on the final? Okay, if you can crunch it out. Does that make sense, the way we approached it? Full circle, then sector, triangle, then subtraction. Okay? Poor guys, work. Thank goodness that it's gone. It's time for a break. Okay, so let's take a 10-minute break.